Hello everyone. We're going to look at basic rules of probability. Specifically, our focus would be on multiplication rule. In the previous video, we talked about complement and addition rule. Here, we are looking at multiplication rule. So what is a multiplication rule? A multiplication rule simply means to find the probability of intersection of two events. That is multiplication of rule of probability. In other words, we're looking at probability of A and B. Remember, when we use the word intersection, intersection is and. Now, we're going to look at two scenarios that is going to be focused or basically they are concerned with events. Now in this intersection here, whether the events are affecting each other or the events do not affect each other. Now if the events are going to affect each other, when that's the scenario, we're looking at dependent events. But if the events do not affect each other, we are looking at independent events. In this video, we are going to focus on a very special case of dependent events called conditional probability. Once again, in this video session, our focus is on conditional probability. Okay, let's look further into what is conditional probability. Now, the knowledge that one event has occurred will have an effect on the another event is something to be considered. So here when we talk about conditional probabilities, we're dealing with the probability of an event when we know that outcome was in some particular part of the sample space. Okay, so in very simple words, if we had an event, so let's look at a very simple graph of this. Okay. We have a sample space, we have two events. We say event B has occurred. Okay, so if event B has occurred, what is the probability now that another event A will occur, given that B has already occurred? In other words, we're looking at, so now our focus will be more on, this will be our sample space. So we're looking at an event B has occurred. Now what is the probability that A will occur when B has already occurred? So instead of having this whole big sample space, our sample space now is going to be narrowed down to the event B. And then we focus, what is the A happening? So what this sentence says in conditional probability, it means probability of an event when you know that the outcome was in some particular part of the sample space. So this outcome was in some particular part of the sample space. That is the B, guys, we are talking about when this event, suppose, has occurred. Now, how do we give the notation of a conditional probability? It's probability A given B. Now, remember, this is the event we are assuming has happened before. So B takes place first. It says given an event has happened, the event B takes place first. And now when we look at the term probability of A given B, that means given B has happened, what is the probability that A will happen? When a conditional probability happens, guys, it reduces the sample space. When I was explaining the example earlier, that's what I meant. Suppose my B has occurred. What is the probability now A will occur? In other words, now we're going to concentrate on B as being a sample space, and what is the probability of A happening there? So that's what this line says. We calculate the probability of A from the reduced sample space B. Let's look at in terms of a formula, which will help us to really understand more about it. So the probability of A given B is defined as probability of A intersection B divided by probability of B. Now this little vertical line is being represented by, so this vertical line, guys, you see, is the one which represents the word given in the problem. Now the Venn diagram is shown below. So this is the Venn diagram of our conditional probability. Probability of A given B, that means this B event has occurred. You see this one? This whole B event has occurred. First, out of this event B, what is the probability that A will occur? That's the common part here. So the probability in the denominator is always for the given event. So when you're looking at this one, how do you write this? So I'm just going to give you a little examples, just a little hints here. So if I see probability of A given B. Now the moment you see a vertical line, it means, oh, this is a conditional probability. Okay. Now we all know the formula to, some hints are the intersection of these two events will always be in the numerator. The question is, what goes here? Always look at the event which happens after this vertical line. So the event which is happening after the vertical line, guys, here, which is this little b for us, is the one which goes in the denominator. So this is where it happens. This b is the one which goes here. Okay. Now let's do some examples. Now a fair dice is tossed. So what is the sample space? 1, 2, 3, 4, 5, 6. And we're going to look at two events. The first event, the face is 2 or 3. And the second event is the face is even. That is, either it can be 2, 4, or 6. So we would like to find what is the probability that A given B has occurred. In other words, we're looking at what is the probability that B has taken place. And out of that, we would like to say what is the probability that A will occur from here. So let's look at this one. Probability, so applying the formula, probability of A intersection B over probability of B. So let's look at this one. What is probability of B? Remember, it is the number of favorable outcomes. So number of favorable over total outcomes. Now, when I'm looking at this total outcomes, guys, I'm looking at the whole sample space. So it is 3 out of 6. Now, when I say we look at probability of A intersection B, we're looking at the big picture, guys. So A intersection B is what? Number of favorable over total. Now total is 6. What's for the favorable? What is common between A and B? Just a simple 2. That's 1. So when we plug in the values, so 1 over 6 divided by 3 over 6. Let's look at this one. It's 1 over 6 divided by 3 over 6. And when we want to solve it, we take the 3 over 6 in the numerator and we flip that 3 over 6. So it's 1 over 6 times 6 over 3. 6 cancels, we get with 1/3. Now let's look at another example. Here, we are given probability of A to be 0.8, probability of B to be 0.9, probability of A intersection B to be 0.4. We would like to find the probability of A given B. Remember, the vertical line means given. Now we remember the formula. This formula is always on the numerator. It's A intersection B over probability. Now remember what is after the vertical line? B. Now that's what pops up over here, probability of B. We already given probability of A intersection B to be 0.4. Probability of B, 0.9. When we solve this, remember we can remove the decimals. What is the answer? 4/9. Okay, can leave it the answer like that. What is probability of B given A? First, we write down the formula. This is, remember, in the numerator, it's always the intersection of both the terms B with A. Now, what goes in the denominator? Remember what's happening after the vertical line? A. Now, that's what goes over here. So now we just look at the terms, the values given to us. 0.4, probability of A, 0.8. Solving, which we get 4 over 8, which is half, or 0.5. Okay, now let's look at one more example. Now here, suppose 2% of the students are double majoring in agriculture and business, and 3% of majors are majoring in business. Given that a randomly chosen student majors in business, what is the probability that he or she majors in agriculture? So first, let's write down what's given to us. We're talking of students who are majoring in agriculture. Let's make our life simple and we say agriculture is A. Students who are majoring in business, let's say this is B. Now let's read the problem again. It says suppose 2% are double majoring in agriculture and business. So what does the first sentence says? Probability of A intersection B is 2%. 2% means what? 0.02. Then, continuing with the sentence, it says 3% are majoring in business. That means probability of B is 0.03. So we've got down what the first sentence says. Let's read the problem. It says, given that a randomly chosen student majors in business, what is the probability he or she also majors in agriculture? Now remember, whenever we see the word given, the given is a hint that we are having conditional probability. Very important. Let's look at the words first. Given. Given means what? It's an indication of conditional probability. Okay, now any event which comes after the word given is always going to be in the denominator. So that means this business is B, remember? So this is what is going to be coming after the vertical line. It says given that a randomly chosen student majors in business. That's where it pops up. Okay, what is the probability that she or he majors in agriculture? So this one, it says, is A. Now we have written down this conditional probability notation. We are going to just go ahead and write down the formula and then plug in the numbers. Remember B and B here. We get 0.02 from the top divided by 0.03, and when we solve this, we get 2/3, which is 0.66. Okay, the last example here. Let's read this one. It says, studies show that about 1 woman in 7, that's approximately 14.3%, who live to be 90, will develop breast cancer. Suppose that of those women who develop the breast cancer, a test is negative 2% of the time. Also suppose that in the general population of women, the test for breast cancer is negative, about 85% of the time. Now let B be the woman that develops breast cancer and N be the tests that are negative. Now we select one woman at random. What is the probability that the woman develops a breast cancer? And what is the probability that the woman tests negative? Once again, we're going to go back and read the problem again and see how it matches up with the questions we have. The first line says, studies show that about one woman in seven, that is around 14.3%, who live to be 90 will develop breast cancer. So here is the key for us, guys. Okay, let me just highlight again. The first sentence gives us the key. Studies show that about one woman in seven who live to be 90, that's an extra information, will develop breast cancer. So this one is basically giving us the answer for the first question in the first problem. What is the probability that the woman develops breast cancer? That very first line gives us this answer. And we are saying let B be the event that woman develops breast cancer. Okay, so reading the very first sentence, we can write the probability of B. It says 14.3% as 0.143. Okay, let's look at the next question in the same problem. What is the probability that the woman tests negative? Let's go back again to the problem. It says now, suppose that of those women who develop breast cancer, a test is negative 2% of the time. Now, this means the ones who have breast cancer, and out of those, the test is negative. So now, this one is more conditional. This is not giving the answer over here. But let's read further and see where we get it. Also suppose that in the general population of women, the test for breast cancer is negative about 85% of the time. Now, this is talking generally. What is the probability that the woman tests negative? It means every woman that has been in that study was tested for breast cancer, 85% of them got negative. That's the bigger picture we're talking about. And that is the answer to our scenario. So here we say the test gives us a negative answer. Probability of N is 85%, 0.85. Now that's where the answer is coming from. Let me highlight this one in a different color. Let's take this little sky blue color. So the answer for this one, that the woman tests negative. Now remember, this is in general, guys, okay? And that's the blue goes here. It says the general population of women, the test for breast cancer is negative about 85% of the time. So this sky blue and a kind of this are actually same. Okay? When we say the woman develops breast cancer, let me be inconsistent with the highlighters. The woman develops breast cancer is the same as the very first sentence. And that's where you go back and forth between the question and the answer, a problem given to you. Now, let's read the next problem. It says, given that the woman has breast cancer. Now that means given. The moment you see the word given, guys, what is it an indication? Given means conditional probability. Okay, this is conditional probability. Let's keep that in mind. So these are some indicators. Oh, I have conditional probability. Okay. Now, given that the woman has breast cancer, that means B. So when you write down conditional probability, we have to write something which is after the vertical line. So this one, given, is coming here. Now it says, what is the probability that the test of the woman, she is negative here? That means once the woman actually has a breast cancer, and then when you go and do the test on it, it comes to be negative. That's where we're looking at the N. That's what we are asking. Okay. So once again, when we go back to the problem, remember the second sentence? I said it's a conditional probability. That's where it is connected. It says, suppose that of those women who develop breast cancer, that's where it is, a test is negative 2% of the time. This is the answer for our problem. That the test is negative 2% of the time. So this is 0.02. The last problem, what is the probability that the woman has breast cancer and tests negative? In other words, we're looking at probability of B, that means breast cancer, and is intersection negative here. Now, if you go back to the conditional probability formula, remember conditional probability formula is what? Probability of N given B is probability of N intersection B or B intersection N. Let me just write it on the more spatial scenario page here. Okay, let's come back over here. Let me write it over in here. Remember, what's the conditional probability? Probability, now we're talking of N given B here. N given B is probability N intersection B. Remember, that's how we take the two events and take the intersection. Probability given B. That's the B and the B. Now, the question says, what is the probability woman has breast cancer and? That means we're looking at this scenario. So it's what is the probability of N intersection B? Now, what does that mean to us, guys? It's just simply college algebra. In other words, I want to find this part. What do? I do cross multiplication. This over this. Now remember, this is over 1. So N intersection B is N given B times probability of B. That's where we're looking at. Or now N intersection B, guys, is the same as you're writing B intersection N. It doesn't matter which event you put first. So remember, the woman has breast cancer. What is it? 0.143. If you remember that here, 0.143. So when you write this one, solving this, now probability of having a breast cancer is 0.143 and N given B is 0.02. When we do the multiplication, we have 0.0029. So the probability of B intersection N is 0.0029. And that's what we will write over here. 0.0029. Let me erase this one, which we just did here. Okay, thank you guys.